Hello everyone. Welcome to our webinar. I am Daita Sergi, Programs Coordinator with AASHE, and I will be the moderator of today's webinar, the third in the AASHE Award webinar series. It is my pleasure to welcome you all. As many of you know, AASHE's mission is to inspire and catalyze higher education to lead the global sustainability transformation. AASHE members represent around 20% of the colleges and universities in the US, as well as institutions in 20 countries, including Canada and Guatemala. You can learn more about AASHE on our website, www.aashe.org. We provide an extensive collection of online resources, networking tools, and educational events, such as today's webinar and an annual conference and expo, which will be held this year, October 15 to 18, in San Antonio, Texas. Our prices and schedule at a glance are already available, so please visit conference.aashe.org for more information, and we hope to see you there. Just a few housekeeping notes before we get started. Everyone in the audience is on mute, but please feel free to ask questions or provide comments at any point during the presentation. You can do that by typing your questions or comments in the questions pane in the control panel on your screen. If you have additional questions, please email them to webinars@aashe.org and we will get back to you. At the end of the webinar, you'll have the option to provide feedback regarding today's presentation. We take your suggestions into account when planning for future webinars, so please fill out the post-webinar survey, and thank you in advance for letting us know your thoughts. Please note this webinar is being recorded. If you experience technical difficulties or have to leave early, you and others can view the recording later. Presentation materials and additional resources will be available after the live broadcast as well. I'd like to introduce today's webinar presenters and agenda. Dr. Curry is a professor of agriculture and food sciences at the University of Manitoba. His research focuses primarily on understanding the biology, physiology, and behavior of managed and native pollinators and their parasites and pathogens. Jason Hare is Fab Lab Manager in the Faculty of Architecture and performs research in the field of digital fabrication. For more information about the presenters' bios, please visit the webpage of this webinar. Today's project was a winner of the 2016 AASHE Campus Sustainability Achievement Award, and we invited them to share their success, challenges encountered, and lessons learned. At this time, I'm going to turn over to the presenters.
Hello, everybody. Okay, my name is Rob Curry. I'm, as was mentioned, a professor at the University of Manitoba, and with me is Jason Hare. We're going to be doing a tag team performance throughout the presentation, so you'll first hear from me and then Jason. My area of specialty, as has been mentioned, is related to the study of primarily bees, both native and managed pollinators, and the factors that are affecting their declines, things like pathogens and diseases, as well as other factors. I also work on other non-native pollinators that are not bees, such as butterflies and things like that, and study those as well as teach courses in pollination biology. With me, as I mentioned, is Jason.
Hello, everybody. So as Data mentioned, I am the manager of the Digital Fabrication Lab at the Faculty of Architecture. We're an open source fabrication lab that facilitates students within the Faculty of Architecture and outside within the university, and tries to take on collaborative projects such as this one.
Okay, so what we're going to be trying to do throughout the course of this webinar is walk you essentially through the steps that resulted in the project coming to fruition, and tell you a little bit about some of the challenges along the way and some of the things that we believe were critical in making the project a success. The first slide that is up on the screen there with the title Pollinator Friendly City indicates essentially how this project came about. The genesis of the project was associated with a committee that had been struck of major land managers within the city, originally coordinated, oddly enough, by Manitoba Liquor and Lotteries Commission, which is a provincial organization that is responsible for managing both the sale of liquor and things like lottery tickets in the province. And that organization has a fairly large land base and a manager that is associated with sustainability in that. And she was interested in getting together groups of all the major land managers in the city to see what could be done to enhance habitat for pollinators. So the University of Manitoba was included, and our sustainability officer was Ian Hall. We also had myself, who was brought in because of my expertise with pollinators and bees, and members of the Manitoba legislature because their grounds take up a substantial area within the center of the city of Winnipeg, and the city of Winnipeg itself because basically they have a large land mass as well associated with the city, and individuals from the city of Winnipeg that were included were from the Winnipeg Parks Department, the Winnipeg Zoo, as well as the Living Prairie Museum. At that meeting, we started to talk amongst ourselves about things that could be done within Winnipeg to enhance habitats for pollinators, and Ian specifically wanted to find out, what we could do at the University of Manitoba that would make an impact and, be relatively easy and cheap to do. And we came up with the idea of creating greater amounts of nesting habitat for the bees. With that kind of idea in mind, we thought that if we built nests and put them out through campus, we would be able to enhance the diversity and abundance of some of the native pollinators that we might find on campus, and decided that we would try and put up nests, and the sort of genesis of the idea started with that. So we then had to figure out a way to make that happen. Turn over to Jason now.
So yeah, as Rob was saying, what we discussed to try to get across in this presentation was not only the genesis, but the evolution of how this project came about with multiple partners within the University of Manitoba. So this slide kind of speaks towards starting off in the Office of Sustainability in the Department of Entomology, and we'll basically walk through the different departments that were engaged and individuals that played a key role simply by word of mouth to a degree and knowing one another. So really, in the end, the project was attempting to link these different cultures within the university and ultimately across Winnipeg to some degree.
Yeah, and further to Jason's comment, I think that although we now know each other, we probably didn't really know each other very well or at all when this all started. And a major driving force behind coordinating us and getting us all working together was, I'd have to say, Ian Hall in the Sustainability Office. And if it wasn't for his efforts in pushing this thing along, a lot of the stuff that did happen certainly would not have happened. One of the things that Ian did in terms of the first steps was to try and figure out if we're going to put these nests all across campus, how do we do that? How do we build them if we're going to build them? And clearly getting volunteers was key in making it happen, because at this point the project had absolutely no funding. So he decided that he would try and make a connection with some of the student groups on campus and see if there was any interest in basically buying into this project and participating on a volunteer basis. And he made a connection with a campus club that's called Parks Canada, which is basically a collection of students from a wide variety of different disciplines in the university that just have an interest in natural systems and parks and things like that. And people in there were quite enthusiastic about the idea and said, yes, we'll certainly help to build them. But of course, Parks Canada Club didn't have any facilities, so the next step was to try and figure out how that could be done.
So the next conversation that I think happened was between Ian Hall and Kim Wees, and Kim Wees is an instructor in the environmental design program. The Faculty of Architecture has a variety of programs. The undergraduate program is the environmental design program. Kim Wees plays a pretty critical role within the Digital Fabrication Lab, which I manage. She's the director of the lab. So when Ian brought the idea to her, we sat down for an afternoon, and it was something we were generally interested in, because the Faculty of Architecture tends to direct its interest on the genesis of just ideas, maybe without implementation sometimes. The role of the Fab Lab is more about the implementation of the idea, so attempting to create the relationship behind design, function, aesthetics, and ultimately engaging the public. So that was the main connection with environmental design. And as I mentioned at the beginning, the Digital Fabrication Lab, or the Fab Lab, is within the basement of the Faculty of Architecture. We house a variety of tools, stuff from CNC industrial routers to laser cutters, a number of 3D printers. Our interest is really in taking physical information, moving it towards the digital sphere, and then basically outputting that information back into the physical world as some form, structure, or other piece. The studio collaboration has been really important within the Digital Fabrication Lab. This project has played a critical role. We've also done a couple of other projects last year, which have been presented at a number of other conferences, but this particular project was really engaging for the lab itself, but also students within the environmental design discipline. So after the environmental design discipline was approached and also the Digital Fabrication Lab, there was the need to expand beyond just kind of the small, narrow vision of the university, I would even say. And one of the really critical and key goals was, how do you get broad ideas from around the world engaged in this topic of bees? And STUFF, which is an organization run by an individual that is a faculty member at the University of Manitoba in the Faculty of Architecture, Jay Sun-Chon. He has run a number of design competitions globally that engage a variety of topics. So he seemed key in trying to fit all these emerging pieces together. So Jay was approached and brought into the conversation about, what do you think the possibility is of doing international competition that tries to engage the public, either in the design disciplines or any other environmental disciplines, or really anybody for that matter, because it was an open competition, to produce ideas in a juried panel and move forward from there. So between, I would say, these three main parties, Ian, Rob, and Jay, the design brief really started to come together. It was discussed about what type of parameters would be implemented, how far of a reach, who else do we need to get involved to actually output this brief in some way that it gets out to the public, and those are some other topics we'll touch on as we go along.
Yeah, just to reiterate, I guess, what Jason said, the facilities they have are amazing. As a kind of a bee biologist and person involved in fairly simple things, I was kind of blown away by what they could do. And essentially, you know, that lab, if you can imagine it, they can build it. And so we started to think, if we're going to have a design competition, and one of the things that we decided is to put this out on a worldwide basis so that we would attract a wide variety of people, is that ultimately, you know, we would try and put some parameters on there that would provide guidance to a lot of the people that might want to submit designs. We sort of anticipated that many of them would be in the fields of architecture and design, and maybe not know a lot about bee biology, and people that are in the field of bee biology would not know much about design and architecture and how to, you know, put things in a format that could be built. So we set some parameters to help guide the process and make sure that the individuals were sort of targeting the kinds of species of bees that we wanted. And the slide that you see there now sort of outlines some of the simple ideas that were presented. We wanted to keep it relatively small in size because we were concerned about the cost of materials. We did have a plan to sort of build some of the winning designs. And we wanted it to be practical in terms of attracting a wide variety of pollinators. So we designed nests that had a wide variety of nesting holes in them, and sort of put specifications on the size of the actual thing, which were to a certain extent largely ignored by many of the designs that ultimately came in, but they at least provided some guidance. I think once once the idea caught on and we started circulating this, we tried to get it out as broadly as possible using our personal connections, the media offices within the university and within our individual faculties put out press releases. We circulated it to academics that we knew that might be interested in entering design competitions and asked them to circulate them to people they thought might be interested. And it was a situation where I think they told two friends and they told two friends, and it kind of multiplied. And the thing went a little bit viral, and we got really great media exposure, both locally, nationally, and internationally with some of the material we're putting out. So it really got really wide coverage, I think, because people find pollination and pollinators a very sort of exciting topic, and the idea of coupling that with a design competition where they could actually submit ideas and have them tested, I think was something that caught the attention of both the public and the media.
So going back to the jury, in the construction of the design brief, Jason Chon had some recommendations for some jury members whose field is definitely more towards the design field. But both of these jury members, Joyce Wang and Michael Loveridge, specialize in activating their interest through the physical construction of ecology, biology, and design as a whole relationship. So they actually seemed well suited to be design jury experts for this particular project. But ultimately, what I, as a bee biologist, think was one of the cool things is that we didn't leave the entire judging up to the architectural experts. We decided that we should really let the bees judge and decide who had the best nests. So we decided that we would actually build some of these nests. We'd put them out in a wide variety of different habitats, both across campus and in other areas in the city, as you'll see later on, and assess the uptake of these nests by native pollinators and look at both the abundance of bees that would be found within the nests as well as the diversity of bees that each nest would attract. We're also planning on measuring, and ultimately will measure, the effectiveness of each nest in terms of resisting parasites and things that might affect the bees. So we're kind of looking at both the attractiveness of the nest for bees and the efficiency of the nest in protecting those bees that it did attract. Ultimately, for me, this is actually quite interesting because I've gone through a master's degree in landscape architecture and also an undergrad design degree, and often you don't see your ideas realized into some fruition to see them judged by other things, in this case. So the aspect of actually having species be judgment on it was quite an exciting element. So after the brief was launched and the information went somewhat viral, this is a bit of a global interest map of where we got competition entries from. So as you can see, some from around the world. Primarily it was in North America where most of the entries came from, but it was quite exciting to see places like Poland and Germany and Italy and UK get involved. And we know specifically that because of some of the jury members and other types of media was the reason that we got entries from these areas effectively.
Of course, if we're going to fabricate these nests and put them out at different sites in the city and do it in a quasi-scientific way so that we could evaluate their relative effectiveness and the effectiveness of different habitat types, we had to have some money so that we could actually build them. And again, Ian was quite critical in pulling in a lot of sponsors. There were a wide variety of different companies and entities that got involved in one way or another. In terms of providing financial support, Manitoba Liquor and Lotteries contributed. A honeybee manufacturer who was established in Winnipeg just recently, Propolis, etc., became a major sponsor of the event. We had interest and sponsorship from a local hotel, which was downtown, the Inn at the Forks. Dining services at the University of Manitoba contributed in-kind contributions in the form of food for the students. We had some local equipment and I guess material suppliers that contributed. which we don't have on our contribution list here. We had Manitoba government in terms of not cash contributions, but contributions from one of the provincial APRIS in helping to judge. The zoo, the Farm and Food Discovery Center in the Faculty of Agriculture, as well as the St. Norbert Market that all wanted to get involved and contribute by providing land and sites in order to help the project. So we had a huge number of individuals that were quite fascinated by the project, quite interested in it, and in many cases delivered either in-kind contributions or actual cash to help see the final construction phase and assessment phase go forward.
Okay, so I guess I'll run over the winning competition entries. But basically, the way that it was broken up was into two separate categories. We had a student category, and we had an open category, which defined any public individual or professional could apply into the open category. I don't think we mentioned before, but the jury was a blind jury, or they made their selection through a blind jury, which was really critical because the design field, we know specifically, is actually relatively small. So having a blind jury is really critical. But after the entries came in, it was surprising to see how many entries were from outside of the design disciplines, which was nice to see. So the first place winner has quite a nice aesthetic to it. One, it met the design parameters almost spot on, and it had a kind of playful aspect to it that a lot of the other competition entries didn't really have. And the playful aspect here was a little bit of a play on color and the idea of putting a UV paint, which humans effectively wouldn't see, but the idea is the bees would see, and it was this poem to the bees, kind of encouraging them to come towards the nests. This is an example of a well-crafted, I guess, design entry. You often don't see entries broken apart into detail in terms of assembly and construction, but this was really nice to see, especially for the jury, and ultimately on my end, being the one fabricating, to get a really clear idea of what this entry is trying to get across and how fabrication actually might happen. What I realized as the entries came in, that a lot of tweaking would have to happen on the fabrication side, only because some materials weren't even quoted, or forms were simply generated without expressing how they'd actually be made or fit into some standardized format. So this is, again, the last slide of the first place entry. The second place entry was this X and O entry, so it ended up being two separate hives that we constructed. Again, it actually fit the needs of the bees quite well because of these hole dimensions, but then it was kind of encased with this, I would argue, beautiful facade. So we worked hard at trying to communicate these design intents into the final form. Also, one thing I don't think we mentioned earlier on is that through the process of the competition, we didn't know the exact number of houses that we would construct, but that was really determined by the land that we had available, places that we would go, and ultimately the total winning competition entries. So there were 3 winning entries from the open category and 2 from the student category, and what we ultimately decided was that every site would have 1 unit on it.
One of each.
One of each, yeah, resulting in a better study selection. So this, again, is a nice example of the breaking down of the pieces, the components, and the assembly of the parts. So in some ways, it was easier to make a choice for a winner, I think, for the jury. The third place winner was a curious one. So they were constructing an idea based on the supposition that bees effectively like gnarly holes, and this is where they go to live and other such things. So the idea was that if you could simply mimic the hole structure, the bees would effectively enjoy going into this type of form. So this was actually quite a challenging one, but something that the lab was kind of up to because it required the 3D printer, and in fact we 3D printed 5 of these models. Sorry, I'll just go back, because actually there's a kind of interesting aspect in terms of information flow from the competition winners. So as you see on the slide, they produce this white form. Now, that form is very organic and hard to digitally model for 3D printing. So what we had them do was take a series of images walking around the mold, and then they sent us the images, and we have a program which stitches those images back together and makes a 3-dimensional model. So they basically sent us the model via pictures. We stitched it back together as a physical model, and then we 3D printed it out. This was a patterning that, again, was attempting to mimic the idea of a camouflage on a tree. Unfortunately, some of the projects, because we were doing such volume, 70 hives in total, we didn't have the ability to execute all of them to their final state. The first place student competition, this was kind of an interesting one because it was attempting to encourage the habitation of the bees, but also to have individuals kind of sit and contemplate while they're beside them. It's a very interesting project. Some of the challenges that I found with it was a bit of material waste because it's all flat pack pieces and they don't fit nicely together. There was quite a large volume of material waste. But again, you can see what a competition entry might look like that communicates really the design intent, the material construction, and the material itself. So finally, the second place winner, this was definitely another playful one. If anyone has seen the movie The Wicker Man with Nicolas Cage, they were generating their idea off the end scene of this movie where bees are effectively flying into his mouth. So their suggestion is that we made in some format, a replica of Nicolas Cage's head and then simply put it in a cage. So personally, I have to say this is actually quite fun to do because constructing somebody's head is very difficult. So in the end, what we did was we have a 3-axis CNC mill. We basically took a piece of cotton wood, we chainsawed it in half, basically splitting the face down the middle, and we milled out one side of the face, milled out the other side of the face, flipped it over, and made pockets inside the head. And when you put the head back together, the bees could effectively fly into his mouth. It was exceptionally challenging to do, so we only ended up producing one of these ones, although I think it was still my favorite one to fabricate.
One thing that Jason didn't mention is that the design jury was actually given sort of feedback by both himself in terms of the ability of an entry to be fabricated as well as the potential for it to attract bees. And both David Osterman, who works for the provincial government, and myself, Rob Curry, provided feedback to the design jury on suitability for bees. And I suspect they probably largely ignored that advice for some of them and just went for the coolness factor. And it was really great to see those things actually built and actually test them, because as a scientist, you don't want to prejudge. And we have all these preconceptions, so it was great that they just built what they thought would be neat and we could actually test it.
Yeah.
The sites that you see on the slide there are sites that are around the city of Winnipeg that were selected for a variety of different reasons. The big loop, there's the river which surrounds the campus, and there are agricultural lands in the center of that loop that are used for field plot testing. The central part where there's quite a few little white numbers there is the central part of campus, which is a very urban environment. Moving off down towards the kind of left of the photograph there are, again, more sort of agricultural sites. One is a site where there's a campus garden that is used for growing local food by students who live on campus, and another site which is very close to a sort of a natural prairie type of habitat on campus. Going north, there's a site which is an old golf course the university has purchased, and it's kind of gone to seed a little bit and is a great sort of site with a lot of natural habitat on it. When you start to move off campus, We also had sites that were associated with some of the people that were interested. The Farm and Food Discovery Center is run by the Faculty of Agriculture, about 30 kilometers south of the city, and there were great public education opportunities there, so we located a set of nests there. In at the Forks is right in downtown Winnipeg. They were one of the sponsors of the project and were quite excited to have bees outside of their hotel. So we located some outside of that hotel and tested the designs there as well. And the final sites where we tested them were again associated with a food market, St. Norbert Food Market, and the Assiniboine Park Zoo. And although we're not going to be presenting data on this today, we have data on the effectiveness of bees at these different sites. And I'd have to say, just looking at the data, there are a few really big surprises, and that some of the sites I thought would be most attractive got no bees, and other sites that I thought would be kind of a very sterile environment, did attract a large number of bees. So there are some interesting surprises that we're going to get from the actual data there as well.
So after the installation sites were chosen, then we started to move on to fabrication because now all the pieces were effectively in place. So I was charged with obviously the fabrication side of things. Within the lab, we have student techs that work there all year long. So this is actually a great opportunity to hire 2 more student techs to work for an extra 3 weeks or so, helping fabricate all 70 of these beehives. It was an exceptionally tight timeline. I think we had 2 weeks to effectively fabricate all 70 of them, and some of them were very detailed. So in the first slide here to the left, these were the seating units for the first place student winner. On the right-hand side is the Knaves Be Honest shell, effectively, and then standard sandwich-like
nesting material.
Nesting material was slipped into this cowling, effectively. So originally, I was quite interested in the Knaves Be Honest, the right-hand slide, because I thought it would be quite easy to fabricate, but it actually turned out to be the most labor-intensive one. Yeah, I guess just a point of interest. So here on the left-hand side, you see us fabricating the cage for Nicolas Cage's head. So these were brass rods that were brazed together. And the upper slides are showing a little bit of the assembly of the parts. So the challenge we really found with some of these is that, as with all forms of digital fabrication, people tend to want to use plywood as the fundamental building unit of any type of form. But plywood doesn't perform very well in exterior conditions unless you're getting marine grade plywood, or if you're finishing them in some extensive way, but we didn't have the time to simply do that. So effectively, all these nests were looked at more as prototypes. The bottom middle image is a jig that was custom made to mill out hundreds of maple pieces all at once. So that jig goes on the 3-axis CNC mill, and then the mill could come. You could just lock these maple pieces into the jig, and then the machine would simply mill out these very complex interlocking joints. Then finally, after we were done fabricating, it was simply a matter of assembly. And while we were fabricating, we were in kind of constant conversation with the designers to try to stay true to their idea to the best of the ability that we could, while still being realistic about material type, assembly, and timeline. So the goal was really to produce hives that could be assembled on site quite quickly, because we knew we were only going to have a day effectively to deploy them. So how these hives locked into a piece of oak, which was hammered into the ground, became quite critical, because we could only be on site for a short period of time.
In about mid-May, it was the day when the rubber literally hit the road, and we had to go out and install all these nests. And the photograph you're seeing there is just a trailer which was attached to one of the car and some of the Department of Entomology trucks. We got a large number of student volunteers involved at this point from Parks Canada, and they were there for the entire day, driving around trucks and installing the various nests at each site, putting them out in a sort of scientific design where they would randomize the position of different nests in different sites, categorize what was at those sites, and basically make sure that the nests were nice and securely installed. The next series of photographs sort of show the actual installation period. This is the XO design, the X portion of it. You can see the nesting holes up at the top of the sort of design right here. It's a very unusual sort of conformation, and I was of the opinion when we were putting them up that this was not going to work at all. We would find absolutely no bees in this design. The next one is the O portion of this, and the idea here is that the bees would nest in these channels along the outside. This one I thought would actually possibly work much better than the X design, with my bias as a bee biologist, although it was somewhat flawed in that the ends were open on both ends, and bees typically don't like to nest in open tunnels. This one here is the one that was called Suburbia. It was the student design, and it was a really large sort of a nesting thing that had bee nesting material enclosed within it. I thought this one would be good because it would protect the bees within it from predation by birds and things like that. The site that you're seeing it installed at right here is one of the community gardens at the St. Norbert Market. It's a local farmers market, and there's a community garden where they grow produce for the market right beside it.
So every site was also fixed with a piece of signage so that the public could actually understand what they were looking at and maybe appreciate what was going on in this complex project. Some sites were appreciated, others maybe not so much. That's one thing we realized. The public maybe has a variety of opinions with these types of installations, and it kind of depends on where they are. Some might get destroyed, some maybe not.
One thing that we haven't mentioned to this point, but it was really critical, is that our central administration was firmly behind the project. I think from the get-go they were really excited by the idea of getting collaboration across campus with a wide variety of really different units, and they're really excited by the ideas of the synergies that would create, as well as the obvious media interest that that this was something that would capture the public's attention and give a really good profile for the university. So in this particular photo on the far left, we have our Associate Vice President, Digvir Jais, who's our Vice President Research. We have our President of our university, David Barnard, myself beside there. In the center, we have two of the representatives from the sponsors, Propolis, etc., and Manitoba Liquor and Lotteries Commission. On the second from the left, we have Ian Hall, who is the Sustainability Officer. On the far right there is Jae Sung, the professor from architecture who came up with the design element competition component.
So the university actually did a really great job of making a real launch out of this. So in the day of the installation, there was a media conference, there was some food, and then effectively we all dispersed and we did a bit of a show and tell, not only on the pieces that were created, but also of the two labs that played a fundamental role in realizing this, both the Digital Fabrication Lab and Rob's E-Lab. So that, yeah, this is basically just a bit of a show and tell that occurred during the day of installation.
Yeah, and the individuals in this photo again are the executive from Propolis, etc. in the center. There's the Vice President, Digvir Jais, on the left, the President of the university on the right, and then the Dean of Agriculture. And the Dean of Engineering was also present on that day, but not captured in this particular photograph. Those are our bosses. The next kind of phase in the project was really at the end of the year, and I'm really skipping out a little bit here because we're jumping to the end of the story. And during the year, I think Jason and I both had to every once in a while go around and rescue or save nests that had been either tipped over by the wind or otherwise vandalized in some way or another. So there were components to activity throughout the summer and just in maintaining these nests, but At the end of the year, this is a picture which is taken in very early November. We, at this point, went to collect the nests, which would have bees that have gone dormant and are ready to hibernate, essentially, for the winter. Native bees like this normally go through a period of diapause and would stay in their nesting tunnels throughout the winter. So you're seeing one of the sort of native prairie-like sites, which is on the university campus. And the picture on the right is a picture taken right through the O design of X's and O's. And you can see the places where the bees might nest in those tunnels. Following that, actually in early January, we again got the Parks Canada students together to start processing the nest material. And essentially what we have to do here is strip the bees out of the nest and put them in little incubation trays. And on the far left there, you can see the suburbia design, which was the large sort of design. And in addition to collecting bees, we collected squirrels and we collected birds. And you can see the nesting material collected by either squirrels or birds in that photograph coming out of that nest. And somewhere in that nest, along with all that material, would be some blocks which may or may not contain the bees. The central photograph is one of the sheets taken out of probably the knave's nest and split apart, so you can actually see in the center there these little cigar-like entities. These are a series of nesting structures or cells that the bees would construct, and inside of here you'd probably have about 6 different individual bees that are going through that hibernation phase, trying to winter. On the far right of the slide here, each one of these little cells would be broken apart. So you'd probably have about 6 different cells here, and a separate cell would be put in each little sort of crate here. This crate is then sealed over with glass and then put in an incubator at 5 degrees Celsius to complete diapause. And in about another couple of weeks to 3 weeks, these will come out and we'll warm them up to about 30 degrees Celsius and allow the bees to hatch out so we can actually identify what species are there and figure out which nest had the most diversity of bee species. The students were quite involved in this process, and I have a graduate student as well who's doing this as part of a course that he's involved in. There is quite an element of student training in the component as well as research. And these are some preliminary results as to who won. And interestingly enough, the nest that was selected by the design jury of non-bee people that were interested in architecture is also the one the bees found most attractive by a long shot. Over 246 cells were found in the knave's design, and it had usually a fairly high number of bees per tunnel in tunnels that were infested. The second winner is one that I thought would not work at all. That was the X design, and it actually did fairly well with over 43 bees attracted to the nest and fairly good diversity of bee species that were in there. When we designed this, we had tunnels of different sizes, and normally different species will live in tunnels of different sizes. So we're kind of at this point thinking that design may actually have some of the best diversity of bee species. The third winner there is Suburbia. That was the student design that sometimes attracted birds as well. In addition to birds, it did attract bees, and you can see we had over 75 bees in there with slightly fewer bees per tunnel. So it might be a toss-up between whether you declare Suburbia a bee or the X design a bee. The Suburbia actually attracted more bees than the nest design, but sort of less bees per tunnel on average. The other 3 designs scored 0 there, but that's not necessarily because they didn't attract any bees, but because no bees survived. The O design that I thought might work reasonably well actually did collect some mud nesting bees, we think, but all of those cells were destroyed, so they were probably eaten by parasites or predators or beetles or something like that. So although it scored a 0 here for the O design, there were actually some individuals that were attracted to it. Similarly, the tree cavity also attracted the odd individual as well, but unfortunately all the cells that were in the tree cavity design didn't survive. So the graph that you're looking at is essentially live bees. Unfortunately, Nicolas Cage's head didn't attract any bees, but I'm sorry to say that Nicholas Cage's head wasn't out for as long as the other nests, and he did experience having his nose set on fire at one point during the summer. So I think that may have contributed to the lack of bees found in that particular site. So I think that sort of hopefully gives you an encapsulation of the way the project went out. We were very excited by it. I think all of us were really bought into this and certainly donated our personal time towards it and a lot of our personal resources to it. And we're quite excited to be involved in it because it was, generating so much attention, and there were so many interesting things that could come out of it, with the ultimate winner being the environment around the university and other areas in the city. With that, I guess we've sort of concluded what we wanted to say, and if anybody has any questions or thoughts, this is a time when we'd be happy to address them.
Thank you so much to our presenters, and we will now turn over to the questions. Before I start with the questions, I want to remind everyone to send your questions via the pane on the GoToWebinar control panel. So the first question we received is the following. Is the greatest limitation to native bee populations actually a lack of nesting areas? Wouldn't our efforts be better spent exploring ways to reduce pesticide use and increase bee forage in urban landscapes?
Yeah, that's an excellent question, and certainly both of those activities, particularly increasing the amount of floral forage available for bees, would be a very, very important thing to do. When looking at the University of Manitoba campus and the diversity of forage available for bees on campus, we kind of took a look at that, and in the University of Manitoba, my lab keeps honeybees on campus and also has done studies of native bees on campus, and we know that there is an abundance of diverse sources of forage on campus. So in terms of diverting resources to improving the situation, we thought that the campus was actually pretty well positioned in terms of forage availability, and you'd have to put a lot of money into expanding plantings, so it was kind of lower down the priority list. In terms of pesticide use, again, the campus encourages integrated pest management, and being in the Department of Entomology, looking at the compounds that are on campus, because we keep bees on campus, we're always harping on the university not to spread toxic compounds that would hurt our bees. So it again was, although an important issue, not something that we thought would give us the biggest bang for the buck. So that's the reason why we focused on nesting habitat, which was in short supply.
So some of the goals that were in the onset too is increasing public awareness across the field. So we know that graphically these types of habitats draw people in, and by having signage, it increases public awareness of challenges that exist within the environment and things that individuals could possibly do on their own to increase pollinating habitat, but also hopefully open up or expand land sanctuaries.
Thank you. Were there any city policies or bylaws that restricted the placement of these nests in certain locations?
That's another excellent question, because the City of Winnipeg has historically not allowed the keeping of honeybees within city limits. They recently, about 1 year ago, approved a downtown beekeeping bylaw, but there is no regulation or bylaw that is kind of directed at native pollinators. So because we weren't actually introducing invasive species or species of bees that were not native to the area, just providing nesting habitat for bees that might already exist there, and enhancing that habitat is not restricted by any bylaws. There were certainly lots of questions from university lawyers about potential risks and stuff, but I think once we pointed out that these bees are not very aggressive, that they already exist on campus, and we were just really enhancing an already existing population, that there would be very little actual risk of stinging incidents associated with these nests.
Thank you. What challenges occurred while attempting to navigate between so many different parties with a variety of interests?
I think in some ways there was a number of challenges that were presented, but the things that probably made it quite a bit easier is that all parties involved in the project were of an open mind and quite easily willing to get over any type of challenges that came about. So having I guess progressive, positive attitudes around projects like this really helped navigate the complexity and the scope of the whole entire project. In terms of specific challenges, nothing really comes immediately to mind.
I guess, yeah, from my perspective, the Sustainability Office and Ian Hall were central to making it work through the coordinating role that Ian played. And, you know, any problems that we did discuss normally were quite handily taken care of by Ian. And, you know, if it came to getting funding and stuff like that, we would give him ideas and he would go out and pursue it. In terms of a lot of the coordination between the student groups and my lab, the student groups and Jason's lab, you know, Ian normally made those connections and facilitated it. So I think a lot of the problems that could come up here are kind of all about getting people to work together and do so in a coordinated and timely manner, and having one person take over that sort of coordinating activity and show that dedication and interest, I think, was really critical to the success of the project. So.
Thank you. We have one last question, so I'll remind all the attendees, if they still have questions, to send them now before we go over the last one that we received. So this question is, what is next for this project?
Yeah, so as soon as the project wrapped up towards the fall, there was already talk about, do we host another competition to build on the knowledge that was gleaned through the summer and then now into the winter. People's schedules have been quite busy, so we haven't really gone past that in terms of the Bee House lab for a second iteration. And maybe that has a little bit to do with Rob's lab. Actually having hard information, I think, would be really critical to do any type of second iteration. With regard to the Fab Lab, we often host workshops. So we're attempting to do a design charrette workshop this spring with a local apiarist and try to build on some of this knowledge, but it's a little bit more dedicated towards honeybees.
Thank you. And I want to thank you, Jason and Robert, for sharing your expertise with us. I think I learned a lot, and it was a very interesting webinar. I will now just remind everyone that our next webinar is in a week on March 8th. Titled Sharing the Load, Aggregating Renewable Energy Purchases with Others, and it will feature MIT's innovative procurement strategy of large-scale renewable energy, which is part of an aggregated purchase with 2 other buyers. So please go to our website and register today. And you'll also find the schedule of our future webinars and workshops and information about the next year's conference, well, actually, this year's conference, our next AASHE conference, on our website as well. A reminder to please fill out the post-webinar survey, which will show up on your screen once the webinar ends. Thank you again to the panelists for your presentation and sharing your expertise with us, and thank you everyone for attending. If you have additional questions, please feel free to contact us either at webinars@aashe.org or my personal email, which is on your screen. The recording and presentation materials will be available in the AASHE Campus Sustainability Hub tomorrow, and you will receive a notification once they are uploaded. Have a good day, everyone.